In this video, I'm going to show you what a classifier is, how to create and fine-tune one, and ultimately how to use it. But first, what is classification? Classification is a type of supervised machine learning algorithm where you differentiate between different data points from examples that you give it. One thing that's worth mentioning before we get going with the classifiers is that clustering is very similar to classification. Rather than being a supervised machine learning algorithm, it's an unsupervised one. So rather than specifying the amount of classes that you want, you give it some material, then you say, I would like 3 clusters from this or 4 clusters from this or whatever you want. And in the end, it outputs something that we can use exactly the same as we would as all the other classes. So this is the kind of unsupervised analog to classification. So here I'm going to walk you through a few things of how to set up a classifier, how to train it, what are the options, how to optimize it, and how to get some more out of it. So the first thing here is we're going to train a basic classifier here. So here I have some of the examples that come bundled with it. So here I have some drum playing. This could be any instrument that you want. In terms of what I'm going to analyze, it'd be worthwhile watching the descriptor tutorial and the onset detection tutorial because both of them will help you get the most out of this. So we do want to fine tune the onset detection within the algorithm. And then in terms of what descriptor you're actually going to use for the classification, this is where you want to decide what you find interesting. So for the most part, I use MFCCs for my classification. You can use other descriptors. The main thing to consider here is that you want to capture and encode what variation you will have between the different things. So MFCCs do a really good job of classifying timbre irrespective of loudness and pitch. So in that sense, it's really good for making classes of certain types of sounds where if you play the sound louder or quieter or at a different pitch, it will still recognize the class. That's the idea. It doesn't always work out perfectly that way, but that's what that is about. If I want to specifically make classes that encode loudness or pitch or some other descriptor, in that case, you could then use the corresponding descriptor here instead of MFCCs. But MFCCs are what I use as my core classification algorithm. So coming out of MFCCs, I'm going to be using the buffer outlet. That's what we typically use with the classification or corpus or concat matching where we want to do some other more complex process. So I'm taking the buffer output here. Now here I've got the just drum audio. So here I'm playing the center, the edge, the rim shoulder, and the rim tip. So if I want to train this as a classifier, I can send whatever names I want here. I put them 1, 2, 3, and 4. It could be edge, it could be descriptive, it could be symbols, it can be numbers, it doesn't really matter. So I'll select the first class, I'll hit train, and I'm going to send it the audio. Down here we can see the amount of hits that are going for that class. I'll talk about that in a moment, but first let me train this classifier up. So once it's done, I'll switch to the next one. So you can see I did about 50 hits there. Now, ideally you want somewhere between 50 and 100 hits per class. You can get away with less. I've trained classifiers with as few as 5 to 10 hits. You want something in the 50 to 100 range. You don't necessarily want to go beyond that because at some point you start getting diminishing returns where you can overfit or have some a classifier that's too kind of filled around the nooks and crannies of that specific set of audio. So overfitting is definitely a concern. So somewhere between 50 and 100 is a good safe bet. So once I've given it that audio, I can turn off training. It tells me the total here was 226. And the way that the class create is set up is that if I just play audio into it now, you can kind of audition that it's working. So in this case, I can see that it's triggering the samples. So what I can do is I can write this file to disk. Now there's 2 types of classifiers that are built into class create. The default one that I've just trained now is the KNN classifier, meaning K nearest neighbor. So that just does a distance matching to find the nearest neighbors. It's kind of a brute force algorithm. It works really well. And it's actually honestly what I use most of the time. There is an alternative though. There's an MLP classifier. So that's a multi-layer perceptron, which is basically a neural network. So once I've given this audio here, if I want to train the neural network, I can toggle this on and I'll see the loss go down. It'll vary on the type of material, how many hits, how many classes and all that. With this, it'll train very quickly. But if I run this, You can see the values. They kind of go down. You want to run this value so it goes down some, but you don't want it necessarily get down to 0. This starts getting a little funky with neural networks, but you can also overfit this. So I trained that, the loss got pretty low. So now what I'm going to do is I'm going to write this to disk. I'll put this on the desktop and say classifier video. All right, so I've trained the classifier. So in here, I don't need to look at it, but it says the classes, the names I gave it, how many hits per, the indices, the means of them that might be useful for other things, the amount of total classes. I also trained the MLP that I can see there. I don't need to look at this to use it, but just to show you what's in there. And now to do something with it. So here I have a playback section. So I've got the same MFCCs, I've got a class match, and then I've got some sample playback here. So to create it, I'll use class create, and you can audition things with it. But then to actually use it, I'm going to use class match and then whatever I want after that. So if I just read what I created here, it'll automatically load the class names into the classifier display. And here on the right with DK Plotter, we can see the classes. So we can see some distinction between the 4 classes here. You can see 2 of them, or one of them, this blue one, it's gotten split into 2 here. I think it still works pretty well. This projection is a UMAP projection, so it's kind of like a folded over thing. So, but in general, I can see that it's split the things quite evenly. So if I go to play here, I'd say that's working pretty well. So one thing to keep in mind when you're training the classifier is that you want to train just the classes that you intend on using. So for example, here's a classifier that I've trained using all of what would be the sensory percussion zone, so 10 different zones. So if I load that up here, you can see these are all the zones that were trained and all the examples within them. If I send the same audio to it, it'll work for a bunch of them, but some of them it'll get the wrong hit. So just have a look. So you see sometimes it identified what is a rim tip, but with a cross stick because they're kind of similar. And here you can see I perhaps didn't do enough hits in these. You can see that these yellow ones and these gray ones are quite overlapping. The brown ones are a little bit all over the place. So I could probably have done a better job of training this classifier here. Whereas if I load this one, this is the one that was trained before. Or if I load this one that was from the desktop, I can see the distinction's a little clearer and I get better accuracy with it. So in general, you can train very, very comprehensive classes, but keep in mind that the more classes that you train, the more likely or the more possible that it is that you might get the wrong class in there. Now, in terms of what comes out of class match, by default, you'll get the class name, and that's basically it. You also have the option to output an index. This could be useful if you're not necessarily interested in having so it'll send out the index of it. So you're not necessarily interested in dealing with whatever the name of the thing is. You only care that it was the first class, the second class, or the third class. That makes it easier if you're using a generic bit of patch after it, where you're using select or root. And then there's also this option to do a normalized one where it'll send out a float value. So you can have an infinite, well, however many classes you want, and it'll always give you a value between 0 and 1. So you can set this as to what kind of class you want to get. Okay, by default, it's set to class name. I generally use index quite a lot just because it makes the patching afterwards easier. Okay, so that's the basic setup of how to load it and what are the outputs. So I'm going to show you some use cases with the classifier. So here I'm going to be triggering some samples, very similar to what I was doing with the 808 samples in the background, but here I'm doing a few things. So I've loaded up here in class descriptors. So all of the descriptor types have class variants. So what this is, it's a classifier and descriptor analysis all in one. So this will spit out a class name, or in this case, I'm spitting out the indexes, and then it'll spit out the descriptors along with it. So it's a useful thing if you want to combine things. So here I'm matching class 1 and 2. This is coming out of here, and I'm using the loudness from the descriptor analysis to adjust the volume of the playback. So here I'm triggering the 808 kick and snare just as I was in the main patch. The only difference here is now I'm applying the volume from the playing to the playback of the sample. Whereas in the initial one, I was just playing the sample full stop. Then when I hit the third class here, I'm going to do a 50-50 chance of either triggering a toy piano sound or in this case, triggering a melodic thing. So I'm using controller pitch to make a generic melody within that range. So that sounds like this. And I've turned the sensitivity down there so we don't have like a massive flurry because there's some fast playing in there. But here's a sort of a medium complex thing of playing back samples, applying the volume to it, and then in this case, varying, playing like a random melody from that. We can also use the classification to fork different processes. So again, here's another class variant. So this is class kitchen sink, and the kitchen sink spits out descriptors, melbands, and MFCCs all at the same time. So this is basically the kitchen sink of most of the descriptor analysis types in here. So I'll load this classifier. Here it says clustering. As I mentioned earlier, clustering is just an unsupervised version of classification, but in the end, you get the same thing. You just get, in this case, 3 classes. So when I give this audio, it's going to come out of these 3 things. And whenever it's class 1, it's going to come this way and do some banjo playback. Whenever it's class 2, it's going to do this car plus strong, and whenever it's class 3, it's going to go to this 4Cs example, which is just a synth. So the classification in this case is just being used to fork the different processes. So in this case, it's doing corpus playback, or car plus strong, like physical modeling or synthesis. So the class is being forked to do 3 completely different things. In this example here, I'm using classification to apply different effects to a sound. So here I've got a beatboxing example. I've got a beatboxing classifier trained up here with a kick, snare, and hi-hat. And then it's going to do a different audio effect for each hit. So whenever it's a kick sound, the audio is going to come out of here and it's going to do an overdrive. Whenever it's a snare sound, it's going to go through a bit crusher. And whenever it's a hi-hat sound, it's going to go through a high-pass filter into a convolution through like this old bell. Sounds a little bit like a bell kind of hi-hat sound. So we get something that sounds like this. So in this case, I'm using the type of class that's trained up ahead of time from the classifier. I only want certain types of sounds to have certain effects. So using a classifier, I can apply those effects that way. Now here we have a couple more kind of advanced speculative things if you want to go a little bit in the deep end and play with some more advanced ideas with how to use a classifier. So here's an example that's doing something a little bit more complex. So what I have here is a cascade of classifiers. This first classifier being one that separates just between the head and the rim. And then within that, I have 2 separate classifiers that will fork out the different paths from there. So the way that I did this is I set up the first classifier using a KNN, so which is just the brute force one, which is just good at differentiating things in general. And I give it one class where I gave it both the center and the edge hits. And then the other class was playing the rim shoulder and the rim tip. So that's this first layer of classifier here. So if I'm playing on the head, it tells me it's a head and it passes information along. And if I'm playing on the rim, it tells me it's a rim and passes information along. And then for each of these 2 classifiers, what I then did is I trained an MLP, so the neural network one, to then differentiate between the center and the edge, and then separately the rim shoulder and the rim tip. The idea here being that I can use the more brute force classifier to differentiate the general types of sounds, and then in here, the more nuanced ones. So in this case, it works slightly better than what I have in the background here, but this could be quite useful if you have, for example, very different categories of sounds and the very subtle variations within that. So let's say I have like a whole bunch of bells or cowbells, and I want to differentiate those, and then I have completely different sounds of like playing congos or bongs or something else. It might be useful to use one layer of classification to just completely separate those overall archetypes of sounds. And then within that, train an MLP to have a bit more of a detailed thing within that. So this is the idea here. So combined, it does this. So this works ever so slightly better than the basic version there. I think this is something that would work a lot better with certain kinds of material. In this case, it's only 4 hits, so the improvement is kind of small. But as I said, if you had quite large categories or quite large archetypes of sounds and then subtle variations within that, it might be an interesting idea to cascade them in this way. So this is just an example of how you might do that. So here I have another advanced example. So what I'm doing here is I'm analyzing descriptors and MFCCs at the same exact time using onset frame, which if you want a little bit more information on that, you can look at the descriptor tutorial. But what's happening here is that I'm analyzing descriptors and MFCCs at the same time. Now what's happening here is with the decay filter, I'm using the descriptors to filter the MFCCs. And in this case, I've trained this classifier using the MFCCs. So what in effect I'm doing is I can reduce or choose what things get passed on from the MFCCs. So I can have the classifier trained as I normally would, but then make decisions about what kind of sounds will make it through. And then downstream here, I'm just playing the same 808 samples as before. So if I have this first example here, it's going to be when loudness is greater than -25 dB. So essentially only like medium to loud sounds will make it through the classifier. And that sounds like this. Or I can do other things. So loudness is an easy one to do as just kind of a general threshold in. But in this case, I can do when descriptors are greater than 60. So sort of brightish sounds will only be the ones that get classified. Or in this case, flatness, only kind of noisy sounds. Or combinations of them. So in this case, when the center rate is above 60 and the loudness is less than 25. So quiet, bright sounds. So this is an interesting way to have a classifier that you train on your sounds, but then determine what categories or what types of sounds will actually make it to the classifier. So it's kind of like a hybrid approach here. So in summary, that's basically what a classifier is, how to train it, what the variations of training it are, and how you can use it in a musical way. So hopefully that helps.